The unit that has just finished up was the surface area unit, and surface area is when you cover all the faces. If I'm doing total surface area, I'm coloring all the faces and bases. If I was doing lateral surface area, I was just covering the faces but no bases. We are now moving into the unit of volume. Volume is taking a three-dimensional figure and filling it up with liquids. A lot of the same calculations are going to be the same, and after we do volume, or even when we're doing volume, please pay attention that your volume problems and your surface area problems I can set up exactly looking the same, so you have to pay attention to what you're doing is whether you're doing volume or surface area. Volume will not be taught in isolation. Unit includes naming of the figures. You did this during surface area. And correctly calculating volume of prisms, pyramids, cylinders, cones, and spheres. Those are the only ones that you're obligated to do. Students will need to be able to name the figures: rectangular prism, triangular prism, square pyramid, rectangular pyramid, cylinder, cone, sphere. You'll need to be able to calculate the volume of prisms, pyramids, cylinders, cones, and spheres. You will need to know the relationship that exists between the volume of a cylinder and a cone and be able to apply this relationship. So if you have a cylinder and a cone that has the same base and the same height of a cone and a cylinder, there is a specific relationship that you have to be able to be familiar. The vocabulary for the volume unit is going to be very similar to that of the surface area unit. We will still have big B. It represents the calculation of the area of the base. It's different from little b. You are very familiar with that with surface area. A prism is a three-dimensional figure named by the shape of the two parallel bases, which are congruent, and all lateral faces, which are the sides, or rectangles. A pyramid, a three-dimensional figure named by the shape of the base. The lateral faces are connected to a common vertex, and lateral faces are triangles. Cylinder, a three-dimensional figure that has two congruent circular bases. Cone, a three-dimensional figure that has a circular base in which tapers to a point. Area of a circle is pi r squared. We covered that when we did the area of circles. You also were familiar with calculating that when you were doing surface area of a cylinder. And put a star on this because not only are you going to need to know the definition, but you're also going to have this in application problems during this unit. Giving a cylinder and a cone with the same circular base and the same height, then the cone is 1/3 the volume of the cylinder. Conversely, the cylinder is 3 times the volume of the cone. The story I say is my sister and I used to go get ice cream, and they would say, hey, you want it in a bowl or you want it in a cone? And I loved to get in a bowl because I knew that the bowl would be more ice cream than the cone. There are videos. Here are some links to some videos. You can copy and paste these into a web browser and watch them. You can take your phone and it'll go over videos of volume of prism, volume of pyramid, volume of cylinder, volume of cone, volume of sphere. And now we get into the volume rules. They're going to be on your star charts, but here's volume rules. Prisms, here's all the types of prisms that you can use. I will be focusing on triangular prism, right triangular prisms, rectangular prisms. We don't usually do these as much. And as far as pyramids, triangular pyramids, square pyramids, and rectangle pyramids, but squares are the same as rectangles here. So you're going to name it by its bases. 2 bases are parallel to each other and congruent. Lateral faces are rectangles. And your formula is V. Volume is big B times H. B represents the area of the base. This needs to be calculated separately, just like you have always done. Anytime you have a big B, it is a different formula that you step aside and figure out that. H represents the distance between the 2 bases. So on here, you're going to calculate the area and multiply it by the height. When you're working on a pyramid, I'm trying to get this where we can, there we go. A pyramid is named by its bases. Lateral faces are connected at a common vertex, so it raises to a point. Lateral faces are triangles, and then it's 1/3 big BH. B represents the area of the base. This needs to be calculated separately. H is the measurement from the base to the top straight up. It is always perpendicular. So it's this right here. It is not the slant height. Okay, that's what will mess you up on pyramids. So going to a rectangle, V equals big BH. Going to a point of a pyramid, 1/3 big BH. Okay, then we have cylinders and cones, and they go together. Cylinders, you have two bases or circles are parallel and congruent to each other. Volume equals big BH. B for a cylinder is always a circle, so it's pi r squared. H represents the distance between the two circles. So you're doing pi r squared times H. So you're basically filling all the way to the top. One circular base. For a cone, you have one circular base. V equals 1/3 big BH. B is always pi r squared. So H represents the distance between the two circles. It is the perpendicular height. It is from the center of the circle to the top of the TP. If you notice that whether you have a prism or a cylinder, they're the same formula. If you have a cone or a pyramid, they have the same formula. So it's 1/3 if you're going to a point. There's no 1/3 if you're not going to a point. These formulas are on your star chart. Make sure you're familiar with where they are. Sphere. R represents the radius of the circle. There will be a circle. It's a slice right here or it could be here, but it is the circle within the sphere, and that's what you're going to look for. It can be a radius, which goes from the center to the side, or I can put a diameter and then you need to find the radius. This is a formula. 4/3 times 3.14 times the radius cubed. Make sure you cube your radius, multiply it by pi, multiply it by 4, push enter, and then divide by 3. So those are the formulas for volume that you will have to apply.